everyone, welcome back. So now let's talk about chapter 5, which is probability. So we already start the math stat part, which is going to be chapter 5, 6, and 7. For chapter 5, probability, we have section 5.1, 0.2, 0.3, and 0.4. So we're going to start with the basic concepts, and then we're going to talk about additional rule and then a complementation rule. We also have conditional probability and then the multiplication rule. So a couple of rules that we need to know for probability. And then finally, we're going to talk about some basic counting. And for 4.1, we have 4 parts. We're going to have basic concepts, the classical probability, and then complementary events, and then empirical probability. So you might see, say, events or complementary. For those of term, you might still don't have a clue for what it means, but as we discuss this chapter, we'll introduce those concepts. Part 1, now let's look at a probability experiment. So it is a chance process that leads to a well-defined result called outcomes. So what is outcome? Then an outcome is the result of a single trial of a probability experiment. Then let's look at a quick example. Rolling a single die once is an experiment because it's a chance process. You got equal likely chance to get number 1 or number 2 or number 6. So 1, 2, 3, 4, 5, 6, all possible outcomes. And then a sample space. Now let's look at the term for sample space. A sample space is the set of all possible outcomes of a probability experiment. So for this example, rolling a single die once, the sample space, we use this notation, just capital letter S, and then a set notation. A set notation to represent that. So sample space for rolling a single die once, we're going to say S equals a set notation, all the possible outcomes. And then we use comma to just space all those, 1, 2, 3, 4, 5, 6. Now let's look at this practice. Find the sample space for tossing 2 coins. So for the first toss, we have either head or tail. So coin either going to be land on head or on tail. Then for the second toss, if we got a head, we're still going to have 2 possible outcomes. So head or tail. Then you can have head, tail, tail, head, and tail, tail. So we're going to write it down, use S to represent the sample space. And then the set notation, which is a curly bracket. So we have head, head, tail, tail, head, tail, tail. Then that's all the possible outcomes. We complete this practice problem for writing down the sample space. And basically what we use, we have a name for it. So for this one, we call it a tree diagram. So let's look at another example for a tree diagram. So we're going to use a tree diagram to find the sample space for the gender of 3 children in a family. So same thing. We look at 3 rounds. For the first round, we have either boy or girl, and then for the second round, we have from each cases we have a boy, girl, boy, girl. So so on and so forth. So until the third round, then we finish all the the branches, and then we call it a tree diagram. So for the first rod, we have boy, 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 so we write it down, and then boy, boy, girl, so on and so forth. Then we have 1, 2, 3, 4, 5, 6, 7, 8. So that's our sample space. And then now let's look at the practice problem. Use a tree diagram to find the sample space for the blood type of 2 students in this class. Okay, so now let's see. For the first round, for this specific question, first round, just the first student. So for the first student, we have A, B, AB, and O for the first one. And then for the second one, from each one, we have the 4 outcomes. So A, B, AB, O, and then same thing. Same thing. So this is gonna be the sample space. So if we want to write it down, we're gonna have as equals curly bracket. We're gonna have A and A. That's the first one, and then A and B, so on and so forth until the last one. That's gonna be so A, B, A, B, O. So we have OA, OB, O, AB, and then OO. So we have 16 elements in this sample space, 16 possible outcomes. Okay, now let's look at an event. The definition for this event. An event consists of a set of outcomes of a probability experiment. An event can be one outcome or more than one outcome. For example, if a die is rolled and a 6 shows, this result is called an outcome. Since it is a result of a single trial, then we say it's excuse me. Then we say it is a simple event. Now let's look at the example. Let A be the event. We get an even number after rolling single die once. Then the samples, then the event A gonna be all even number outcomes. So we have 1, 2, 3, 4, 5, 6, and then we just write down the even ones. We have 2, 4, and 6. That's how we write down an event. So just use a different letter, capital letter to represent it. Now let's look at this practice. Let B be the event. We get a number more than 4. So we're gonna write down B equals curly bracket. And then, so all outcomes that satisfies this requirement, number more than 4. So the sample space S equals 1, 2, 3, 4, 5, 6. Then we look at all possible outcomes with this requirement, a number more than 4, so 5 and 6. So this event B is gonna be 5 and 6, and then we write it in a set notation, which is using the curly bracket. So now we got the event B. So that's just part A, some basic concepts. And then part 2, we're going to talk about classical probability. Classical probability uses sample space to determine the numerical probability that an event will happen. Classical probability assumes that all outcomes in the sample space are equally likely to occur. For example, when a single die is rolled, each outcome has the same probability of occurring. So each number got an equal chance. And equally likely events are events that have the same probability of occurring. Same probability of occurring. And then the formula for this classical probability gonna be the probability of any event E is the number of outcomes in this event E divided by the total number of outcomes in the sample space. And then it's denoted by probability of event E. So rate as probability of event E. So this is the stat notation. And then we use number of outcomes in E divided by number of outcomes in the sample space. So this is very important, classical probability. Then for the example problem, a card is drawn from an ordinary deck. Find the probability of getting a queen. So for this one, we only have 52 cards. 52 cards. And then getting a queen. So we have 4 queens, right? 4 queens. So probability, so we're gonna say like A be the event of getting a queen. So A gonna be, so the 4 queens of different colors. And then the sample space gonna be 1, 2, 13, and then 1, 2, 13. So we have 4 of those 13 numbers from ace to king, and then different colors. So now we can just use this classical probability equation to calculate that probability of event A. So probability of A equals 4, because the count of event A, possible outcome, is 4. And then sample space, we have 52. So that's how we use these equations. Now let's look at 4 basic probability rules. The first one, the probability of any event E, any event, is a number. We can express it in either in a fraction or with decimals. And the probability of any event E is a number between and including 0 and 1. So we can use a stat way to express this, which is going to be 0 smaller than or equals probability of any event E smaller than or equals 1. So if your calculation for probability is more than 1, so that's definitely wrong, because this is the basic rule. We only look at no chance at all, which is impossible, 0% chance, or a very certain 100% chance, or something in between. And the second one, the sum of the probabilities of all outcomes in a sample space is 1. Or we can say excuse me, here we go. I have to reply an email real quick. So let's again look at this 4 basic probability rules. We have the first one, so for any event, the probability going to be in between 0 and 1 inclusive. And then the second one is the sum of the probability of all outcomes in a sample space is 1. So we say probability of sample space equals 1. And then if an event cannot occur, its probability is 0. So when you say impossible, so it's going to be 0. And the fourth one, when it's certain, you say 1. That is the same as 100%. So that's part 2, the classical probability. And now let's look at part 3, complementary events. So complementary events, by the name, is just on the other side. So the complement of an event E is the set of outcomes in the sample space that are not included in the outcomes of event E. And the complement of E is denoted by E bar, so E bar. Then if we say, so let's say this is the sample space, and then we use a circle to represent event E. So this circle, empty circle is event E. So everything shaded area we say is not in E, but still in the sample space. So this square is the sample space. Then the shaded area we say it is E bar. And we have a complementation rule. So rule for complementary events. And it is for probability. So probability of event E equals 1 minus probability of E complement. So E bar, E bar. And this plot we just draw, we have a name for it. We call it a Venn diagram. A Venn diagrams. And then again, probability of E bar equals 1 minus probability of E. So probability of E equals 1 minus probability of E bar. They're the same thing. So you're just switch the terms in front of this equal sign or to the left or to the right. Okay, that's part 3. Let's stop here and then we'll continue on the other video lecture.